In this lecture, we're going to look at interest rates and the concept of compounding. These are some of the basic building blocks in modern finance that we're going to use throughout this class. So it's important that everyone has a good understanding of what interest rates are and what compounding is. You hear about interest rates almost every day in the news, but how many people really know what an interest rate is? Interest rates are just the price of money. And the price of money can vary depending on who you are and what the money is going to be used for. For example, you have a credit card overdraft of $5,000 and the interest rate is 18% per year. The cost of borrowing $5,000 is $900 per year. That's the cost of the money. So the cost of the $5,000 for 1 year is $900 for you. In contrast, suppose we look at General Electric. Suppose GE wants to borrow $500 million for 1 year. They may face an interest rate of 4% per year. So the cost of borrowing for GE is $20 million per year. So different people or different companies will get different rates of interest. Now that we think about interest rates as the price of money, you can see how people think about interest rate cuts or interest rate increases. If we cut interest rates, we're lowering the price of money, which means people should use more money. If we raise interest rates, then we're increasing the price of money, which makes it more expensive for people to borrow money. So we'll spend less. Now you can see why interest rates are talked about so much and why the chairman of the Fed is so influential in terms of determining the state of the US economy. Now we're going to start looking at compounding. There are two terms commonly used in finance with regard to interest payments. You can have simple interest, which is interest earned only on the original investment, and you can have compound interest. And with compound interest, you get the interest earned on the original investment, but also on any accumulated interest. So compound interest is actually what you would call interest on interest. Now let's see some examples. First, we're going to consider simple interest. So you invest $100 at an annual rate of 6%, and this investment is going to last 5 years. After 1 year, you're going to get an interest payment of $6. So your ending balance is $106. Your beginning balance for year 1 is $106. But with simple interest, you don't earn interest on the $106, you earn interest on the $100 initial balance. So the interest payment is once again $6. So our ending balance is $112. And we can continue to fill out this table. And each year, the interest payment is always going to be $6 because this is simple interest. And in 5 years' time, our investment of $100 will be worth $130 if we earn simple interest. What happens if we have compound interest rather than simple interest? Here we have the same example. We're starting with $100 and it's being invested at an annual rate of 6% for the next 5 years. Well, over the course of the first year, we earn interest at 6% on our initial balance of $100. So the interest payment is $6 and our ending balance is $106. The beginning balance for the next year is $106. But now, because we're using compound interest, we earn interest not just on the original investment, but also on the $6 of interest paid in the first year. So now we get interest, we get $106 times by 0.06, which is equal to $6.36. That means our ending balance is 112.36. You can see now we've had a bigger interest payment when we use compound interest than when we use simple interest, because we're earning interest on interest. If we go to the start of year 2, we start with $112.36, and now the interest payment is based on the $112.36, so we get $6.74, giving us an end of year balance of 119.1. And we can continue to fill out the table for compound interest. And by the final year, we start with $126.25. We earn interest now of $7.57, which is considerably more than the $6 of simple interest, because we're earning interest on interest. And our final dollar amount after 5 years is $133.82. When we use simple interest, our final balance was $130. The difference, the $3.82, that is the interest on interest. Now you can see the difference between compound and simple interest. In reality, most institutions use compound interest. Now let's consider some more terminology. Annual percentage rates, or APRs. Typically, when you see interest rates, either at your bank or on your credit card, the interest rates are normally quoted on an annual basis. But not all interest rates are actually paid annually. Suppose you owe money on your credit card. Well, you're charged interest not on an annual basis, but on a monthly basis. The question is, who cares? Should you care about annual percentage rates or not? Suppose we owe $5,000 on the credit card, and the APR is 18%. Now suppose the credit card company uses annual compounding. The card company is going to charge you interest on your account once a year. And at the end of the year, because you've had $5,000 in there, you're going to get charged interest of 5,000 times by 18%, which equals $900. That would be the cost of borrowing $5,000 from the credit card company. Now suppose instead the credit card company uses monthly compounding. This is what we see in reality. Well, how much do we owe by the end of the year in interest? The first thing we have to do is calculate the monthly interest rate. We've been given the annual percentage rate, the APR, and that's 18%. The monthly interest rate is going to be the 18% divided by 12, which gives us 1.5% per month. That's the interest rate we will be charged each month. Does this have any impact on how much we owe? Well, let's work through it. We start with $5,000. That's how much we owe. And we get charged an interest rate of 1.5% per month. That means we owe interest of $75 in month 1. The ending balance is $5,075. Now we move to month 2. We've not paid off anything. So now we owe $5,075. And we're going to pay interest on the interest now as well. which means our interest payment has to go up to 76.13. So our closing balance is 5,151.13. You can see now that monthly compounding is likely to increase the amount of interest we would pay on our borrowing. And we can work through this entire table. And what we find is that our interest payments are no longer $900, but $978.10. With monthly compounding, we have paid more in interest than we would with annual compounding. And yet the APR, the annual percentage rate, was the same. That is why it's very important to check whether things are compounded annually, quarterly, monthly, weekly or daily. That way you can work out what's happening and what the true rate of interest is. What is the impact of monthly compounding? We paid $900 on the overdraft of $5,000. But we also had to pay interest on interest when we used compounding. And the interest on interest in this case was $78.10. That means the total interest that we paid out would be $978.10. The most important question to ask whenever you look at credit cards, bank loans or savings accounts is what is the effective annual interest rate? And this is sometimes referred to as the EAR. And the EAR is calculated as the total interest divided by the original investment. If we think about the example above, the total interest paid with monthly compounding is $978.10. The original investment in this case was the $5,000 that we borrowed, which gives us an effective annual interest rate of 19.56%. And yet, remember what the APR was? The APR, the annual percentage rate, was equal to 18%. Now you can see why credit card companies don't quote effective annual interest rates, rather they quote the APR. The APR is always going to be lower than the effective annual interest rate. We actually have a formula for the effective annual interest rate. May look worrying to start with, but the effective annual interest rate is equal to 1 plus the annual percentage rate divided by K, where K is the number of times per year interest is paid. If interest is paid monthly, so the compounding is monthly, K would be 12. So we would do the annual percentage rate divided by K, and then all of this, 1 plus APR divided by K, would be to the power of K. And once we've done that calculation, we subtract 1, and we have the effective annual rate. I never believe formulas unless I can test them out and see them working in reality. So let's think about our example we just worked through. We know we've got a credit card with 18% APR, and we also know we have monthly compounding. What's the EAR? Using this formula, we would do 1 plus the APR, which is 0.18, divided by K. K is equal to 12, because it's monthly compounding. And all of this is to the power of K, so to the power of 12. And then we subtract 1. That gives me 1.1956 minus 1, which equals 0.1956, which equals 19.56%, which is exactly the same number we got on the previous slide. So the formula does work. And whenever you're looking at credit cards or bank accounts, take a moment to calculate the effective annual interest rate. That's what's important. Hopefully now we've introduced the concept of an interest rate and the concept of simple interest and compound interest and the idea of compounding, earning interest on interest. See you in class.